Good evening everyone. I am Dr. Lakshmi Priya Swai, Assistant Professor, Department of Mathematics from SR University. Today I am going to start the topic how to find eigenvalue and eigenvector. So let's start this example. Find the eigenvalue and eigenvector of the corresponding matrix. So let's start. First write the matrix taken as A. Now we have to find the first step. Step 1 to find the characteristic equation. That is determinant of A minus lambda I is equal to 0. So let's find the determinant of A minus lambda I. How to find? Let's start. Let's write the matrix A here. Minus 6, 7, minus 4, 2, minus 4, 3. Minus this lambda I means this I is unit matrix. That's why you multiply lambda with that unit matrix, that is lambda 0, 0, 0, lambda 0, 0, 0, lambda is equal to 0. When you subtract from this matrix to this matrix, you get this type of matrix. This is 8 minus lambda minus 6, 2, here minus 6, 7 minus lambda, minus 4, 2, minus 4, 3 minus lambda, which is equal to 0. Now, you have to find the determinant of this matrix. When you calculate the, all of you know how to find the determinant of this matrix. When you find the determinant of this matrix, you get this equation like lambda cube minus 18 lambda square plus 45 lambda is equal to 0. Now, you have to take one lambda is common. So, you get lambda square minus 18 lambda plus 45 is equal to 0. So, here already one lambda value you have to find, that is 0. Now, you have to calculate, solve this quadratic equation. So, you get another two values like lambda square minus 18 lambda plus 45 is equal to 0. Then when you solve this is lambda square minus 15 lambda minus 3 lambda plus 45 is equal to 0. So you get lambda common here. You get lambda minus 15. Again minus 3 common here. So get lambda minus 15 is equal to 0. Then final is lambda minus 50 and lambda minus 3, which is equal to 0. Now you get another two eigenvalue. One lambda is 50, another is 3. So the eigenvalue are lambda equal to 0, 50, 3. Now you have to find the eigenvector by using the eigenvalue. For each eigenvalue, you have to find one eigenvector. Now you have to find this step. This is the step 2. Now you have to find eigenvector for each eigenvalue. For each eigenvalue. So now you have to find the lambda equal to 0, the eigenvalue. For that we have to use, to find the eigenvector, find eigenvector, the matrix equation is A minus lambda I into x is equal to 0. Let's start. That is, in the previous we know that the A minus lambda is what? A minus lambda is 8 minus lambda minus 6 to minus 6, 7 minus lambda minus 4 to minus 4, 3 minus lambda. Multiply this matrix into x. This x is nothing but x1, x2, x3 is equal to 0, 0. Right. Now you have to find this value x1, x2, x3. This is your eigenvector. And this one is eigenvalue. For each eigenvalue, you have to find this type of eigenvector. How to find the eigenvector? Now you have to put the value of lambda. When you put the value of lambda, this is 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3 minus lambda, which is multiplied into x1, x2, x3 equal to 0, 0, 0. So let's solve this. Sorry. Eight x1 minus 6x2 plus 2x3 is equal to 0. This is equation 1. Second equation is minus 6x1 plus 7x2 minus 4x3 is equal to 0. Is equation 2. The third equation is 2x1 minus 4x2 plus 3x3, which is equal to 0. This is your third equation. Now you have to solve this equation. But for solving, you have to try first two equations, from equation 1 and 2. From equation 1 and 2, we get, like from equation 1, we multiply 2. Zero. It is nothing but 16x1 minus 12x2 plus 4x3, which is equal to 0. Now you subtract from this equation to second equation. It is 16x1 plus 7x2 minus 4x3, which is equal to 0. Now you subtract, add this equation, so you get 10x1 minus 5x2 is equal to 0. Now, here we solve this equation, so you get minus 5x2 is equal to minus 10x1. So here we have to find one value of x2, that is nothing but 2x1. So one of the value is fine. X2 is equal to 2x1. Now move to the next. For the next, you have to put this x2 value in any one equation. So you get x3 value also. So from the last equation, from equation 3, we put x2 is equal to 2x1. We get first step write the equation minus 4x2 plus 3x3 is equal to 0. Here we have to put x2 is equal to 2x1. So you get 2x1 minus 8x1 plus 3x3 is equal to 0. So you get minus 6x1 plus x3 is equal to 0. So x3 is equal to, this is 3x3. 3x3 is equal to 6x1. So here also you get x3 is equal to 2x1. So here x2 is represented in the form of x1. x3 is also represented in the form of x1. Now we have to write the eigenvector for lambda equal to 0. Eigenvector x1, x2, x3 is nothing but, in the place of x1 you have to write simply x1. In the place of x2 you have to write 2x1. Then x3 is equal to again 2x1. Now you have to put x1 equal to k. So the vectors is again, and that k value you have to take any numbers. If it is 1, then the vector is nothing but 1, 2, 2. So this is the eigenvector for this eigenvalue. For this eigenvalue, this is your eigenvector. Clear? So move to the next. Eigenvalue lambda equal to 3. Find the eigenvector. Lambda equal to 3. To find eigenvector for lambda equal to 3. So the matrix is, when you put the value lambda value in that equation, determinant of lambda, a minus lambda I, we get 5 minus 6 2 minus 6 4 minus 4. Last one is 2 minus 4 0 multiplied with x1, x2, x3, which is equal to 0. Now you have to solve this and find these three equations from this. First one is 5x1 minus 6x2 plus 2x3 is equal to 0. Second equation is minus 6x1 plus 4x2 minus 4x3 is equal to 0. The third equation is 2x1 minus 4x2, which is equal to 0. From these three, this is equation 1, this is equation 2, and this one is equation 3. Now you have to solve these three equations. From the last equation, from equation 3, we get one value. 2x1 minus 4x2 is equal to 0. So you get x1 value. x1 is equal to 2x2. So here one value is find out. Then you have to try to solve by putting this x1 value in any equation. You get x3 value. Now put x1 equal to 2x2 in equation 2. We get minus 6x1 plus 4x2 minus 4x3, which is equal to 0. Now you have to put in the place of x1 2x2. So this equation is converted into minus 12x2 plus 4x2 minus 4x3 is equal to 0. So when you solve this, it is minus 8x2 minus 4x3 is equal to 0. Then, but to convert this x3 in the form of x2, because from the first equation you have to convert x1 equal to x2. Now you have to convert x3 is in the form of x2. So minus 4x3 is equal to 8x2. So x3 is nothing but minus 2x2. So to find this two, first x1 is in the form of x2 and x3 is in the form of x2. Now eigenvector is x1, x2, x3. Simply you have to put x1 value is what? 2x2. Then x2 is right as it is, and x3 value is what? Minus 2x2. So if we put x2 value, here we put x2 is equal to k, and that k value is nothing but 1. Okay. So the final eigenvector is what? 2, 1, minus 2. So this one is the eigenvector for this particular eigenvalue, lambda equal to 3. We get this eigenvector. In the similar manner, you have to find the eigenvector for lambda equal to 15. Now move to the third eigenvector. Finding the eigenvector. To find eigenvector for lambda equal to 15. So for lambda equal to 15, the matrix is minus 7, minus 6, 2. This is minus 6, minus 8, minus 4, 2, minus 4, minus 12, multiplied into x1, x2, x3 equal to 0. Right. So now three equations are coming from this. First equation is minus 7x1 minus 6x2 plus 2x3 is equal to 0. Minus 6x1 minus 8x2 minus 4x3 is equal to 0. 2x1 minus 4x2 minus 12x3 is equal to 0. This is equation 1, equation 2, and this is equation 3. Now solve this equation and find the value of x1 x2 x3. So for solving this equation, multiplied in equation 1 to 2, so you get minus 14x1 minus 12x2 plus 4x3 equal to 0. Add to the second equation minus 16x1 minus 8x2 minus 4x3 is equal to 0. Sorry, this is minus. So when you add these two equations, you get minus 20x1 minus 20x2 is equal to 0. From this equation, you get x2 is equal to minus x1. Now use this x2 value in any equation, you get x3 value. So put x2 equal to minus x1 in equation 3, we get 2x1 minus 4 into minus x1, that is plus 4x1 minus 12x3 is equal to 0. So when we solve this is 6x1 minus 12x3 equal to 0. Now you have to write x3 in the form of x1, because in the first when you solve this equation, we get x2 in the form of x1. So from the third equation also you get x3 equal to 1 by 2 x1. So x3 is equal to 1 by 2 x1. So both of this value is in the form of x1. Now write the eigenvector. So the eigenvector is like x1, x2, x3. So this is, so simply write x1 as it is and x2 minus x1. x3 is written as 1 by 2 x1. So simply we put x1 is equal to k. So if we put this k value is 2. If we put 1, it is also okay. But if we put 2, then it is converted into 2 minus 2 and 1. So this is the eigenvector for eigenvalue lambda equal to 15. Lambda equal to 15. This is the eigenvector. So in this manner, you have to find the eigenvector of all the eigenvalues. But the thing is, when you find eigenvector, like 3 equations you have to find, 3 value you have to find, x1, x2, x3. So eigenvectors are not unique. So when you find this value, if you write from the starting x1 is x2, x1 in the form of x2. So simply in the x2 you can't do anything here. But in x3, express that value in the form of x2. So when you write the eigenvector, x1 is in the form of x2, then x2 is as it is and x3 is x2. In the similar manner, if someone finds eigenvector like x1, x2, x3, if x2 in the form of x1 and x3 in the form of x1 and x1 is as it is. When you find x2 in the form of x1, so definitely you have to find x3 is also in the form of x1, so that you write these 3 eigenvector in the form of x1. So put any one value, arbitrary value for this x1 and get final. In the similar manner, if someone put x3 is as it is and x2 in the form of x3 and x1 in the form of x3, so you get the final eigenvector all the eigenvectors in the form of x3. So take x3 is equal to k. In that manner, we have to find the eigenvector. So in these three manners, you have to find the eigenvector because eigenvectors are not unique. So if someone write x1 in the form of x2, so the need to find x3 is also in the form of x2. So all the eigenvector is written in the form of x2. If someone find x2 in the form of x1, so there is an x3 values also right in x1. So that all the eigenvectors, all the values x1, x2, x3, which is written as only in the form of x1. In the similar manner, if someone write x1 in the form of x3 and x2 also write in the form of x3, so that x3 is taken as it is x3. So you put x3 is equal to k and find the eigenvector. So in these three manner, you have to find the eigenvector. Not only x1 is in the form of x2 and x3 in the form of x2, you have to write any one. If you write x2 is in the form of x1, so x3 also you have to write in the form of x1 so that you find the eigenvector easy. Now we have to move the next example. Let's start the example 2. Find the eigenvalue and corresponding eigenvectors of the given matrix. So let's start solution. So now write the given matrix here, taken as A, given matrix A 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Now you have to find the characteristic equation. Characteristic equation is A minus lambda I determinant is equal to 0. So that the A minus lambda I is nothing but 6 minus lambda minus 2, 2 minus 2, 3 minus lambda minus 1 is a 2 minus 1, 3 minus lambda. Determinant is equal to 0. So now you have to solve this. Find the determinant. It is nothing but 6 minus lambda whole into 3 minus lambda whole square minus 1 plus 2 whole into minus 2 into 3 minus lambda plus 2 again so 2 into 2 minus 2 into 3 minus lambda equal to 0. Now you have to solve this. So you get when you solve this, you get lambda cube minus 12 lambda square plus 36 lambda minus 36 lambda minus 32 is equal to 0. Now we have to solve this. So you get 1 value of lambda is lambda minus 2. When you put lambda is equal to 2, you get 0. So lambda minus 2 is one of the roots of this cubic equation. Now when you divide this lambda minus 2 this, you get lambda square minus 10 lambda plus 16 equal to 0. When you solve this equation, lambda square minus 10 lambda plus 16 equal to 0, you get lambda minus 2 into lambda minus 8, which is equal to 0. Now the eigenvalues are lambda is equal to 2, again lambda equal to 2 and 8. These are the eigenvalues. Now by using these eigenvalues, you have to find the eigenvector. Here already who is the eigenvalue? 2 times. So you have to find the eigenvectors for lambda equal to 2 and another is lambda is equal to 8. Find the eigenvalue. So let's move to eigenvector. So let's find the eigenvector. So to find eigenvector for lambda is equal to 2. For that, the new matrix looks like 4 minus 2, 2, minus 2, 1, minus 1, 2, minus 1, 1. Multiplied x1, x2, x3, which is equal to 0 by 2. So, now solve from these three equations. The first equation is 4x1 minus 2x2 plus 2x3, which is equal to 0. This is equation number 1. The second equation is minus 2x1 plus x2 minus x3 is equal to 0. This is second equation. The third equation is 2x1 minus x2 plus x3, which is equal to 0. So now you have to solve this equation. But here in this case, if we add these two equations, there is nothing, no solution. So we want to take any two values, x3 or x2 value or x1 or x2 value, any two value, unknown value as arbitrary constant. So let's take one value is x2, which is k1, another x3 is k2. You have to take like this because in this case, if we choose any two equations, this two equations cancel itself, so that in this case we take two arbitrary constant for the unknown value. So x2 value is k1, x3 value is k2. Now put this value in any one equation. So from the last equation, from the first equation, 4x1 minus 2x2 plus 2x3, which is equal to 0. When you take common from this equation 2, so it's set minus 2x1 minus x2 plus x3, which is equal to 0. Look here, first equation and the third equation are very similar, so that we will take these things. Okay. So now you have to put the values here, x1, x2 and x3 values. So it is 2x1 with 2x1 minus k1 plus k2 is equal to 0. So you have to find x1 value. That x1 value is nothing but this x1 is k1 minus k2 divided by 2. So whatever it is, k1 minus k2 divided by 2, this x1 value. So you have to write this k1 by 2 minus k2 by 2. So now you have to write the eigenvector. Eigenvector, like capital X is x1, x2, x3. So here already we know k1, x1 value is k1 by 2 minus k2 by 2. And x2 value is what? K1, x3 value is k2. X3 value is k2. So you have to take one side k1. So you get, when you take k1, you get 1 by 2, 1, 0. Because here k1 value is nothing. Similarly, we take another k2 here. So, the first, this is minus 1 by 2, and k2 value is nothing, here 1. So, these two vectors is your eigenvectors for this corresponding eigenvalue lambda equal to 2. In the similar manner, you have to find lambda is equal to 8, another eigenvectors. So, this two vector eigenvector is only for eigenvalue lambda equal to 2. Now, let's see what is the eigenvector for lambda equal to 8. So, now you have to find for lambda equal to 8 eigenvectors. So, that equation is looks like minus 2, minus 2, 2, minus 2, minus 5, minus 1, 2, minus 1, minus 5 into x1, x2, x3, which is equal to 0, 0, 0. Now, three equations forming like minus 2x1, minus 2x2, plus 2x3, which is equal to 0. Again, second equation is minus 2x1, minus 5x2, minus x3, which is equal to 0. Third equation is 2x1, minus x2, minus 5x3, which is 0. So, this is the first equation, this is second, and this is third equation. Now, you have to solve this equation and find x1, x2, x3 value. But here, the thing is, the first equation, from the first equation, it is converted into minus x1, sorry, if we take minus 2 common, so it is x1, minus 2 common, x1 plus x2 minus x3 is equal to 0. And the second equation is minus 2x1, minus 2x1, minus 5x2, minus x3 is equal to 0. When we subtract this equation to this equation, what happened? Let's see. So, this value is got, and the value is, this is x1 or 2x1, 3x1 plus 6x2 is equal to 0. So, here 3x1 is equal to minus 6x2. So, x1 value is what? Minus 2x2. So, now you have to check, put this value in any one equation, then you get another value. So, x1 is equal to minus 2x2. One value you have to find out. Then you have to move, put this value in any one equation, like the third equation. Put x1 equal to minus 2x2. So, we get, in which equation? In equation 3. What happened? 2x1 minus x2 minus 5x3 is equal to 0. So, this x1 is in the form of x2. So, we need x3 in the form of x2. So, put x1 is in the form of x2. So, here if we put x1 equal to minus 2x2, it is minus 4x2 minus x2 minus 5x3 is equal to 0. So, that gives a minus 5x2 minus 5x3, which is equal to 0. So, we take minus by common, x2 minus x3, sorry, x2 plus x3 equal to 0. So, x3 is nothing but minus x2. Now, you have to write the eigenvector easily. Eigenvector capital X is x1, x2, x3. Simply you have to write x1 is equal to minus 2x2 and write x2 as it is. x3 is equal to minus x2. Now you have to take x2 is equal to k. So this x2 is equal to k and this k is nothing but 1. So the final solution is minus 2k, k minus k. So eigenvector is minus 2, 1, minus 1. So this is the final solution. So for this matrix, for lambda equal to 8, one eigenvector is here and lambda equal to 2 eigenvectors available in that. So in this manner, you have to find eigenvalue and eigenvector.